Hey, folks, greetings from the Offensive Security Group here at Security 360, coming at you with a new episode of the Cyber Threat Perspective. You've got myself, Brad, and Chelsea here. Chelsea, do you want to do an introduction for us?
Hi, everyone. I'm Chelsea. I'm here to interview Brad about web application penetration testing. Let's dive right in.
Awesome. So, folks, you might notice a little bit of a difference today in our podcast. So, we're going to be um, having a co-host, ChatGPT. Her name is Chelsea, and so interesting, I think, to try this approach and kind of see how much ChatGPT has evolved from an interactive perspective. So, I have not seeded her any questions, and she's going to basically just be interviewing me throughout this process. So, I hope you guys enjoy. Chelsea, take it away.
Thanks, Brad. Let's start with the basics. What are the key stages involved in a web application penetration test?
So key stages would probably start with us interviewing the client, right? We want to understand exactly what it is that they're trying to accomplish with a web pen test. There can be many motivating factors for people to seek out offensive security in the web application pen testing space. That can be driven by some of their clients, maybe asking for a security posture assessment of their application. It could be regulatory, and it could just be that the client wants to, understand where they stand from a security perspective. But it's usually driven by something, right? And we want to find out what that is so that we can make sure that the penetration test will meet those needs. After that, we will scope the application. Scoping usually involves us understanding how the application works, what aspects of the application that they do want to have tested, and we'll usually try to get a good handle on the technology stack the application runs on, right? Is it a LAMP stack? Is it an API driven with a UI and maybe a NoSQL backend? And so we want to know those things, and because that's going to be crucial for us during testing. And we also want to understand how many users and roles exist within the application so that we can test authorization and authentication mechanisms. Finally, we're going to ask how big the application is. That can be in the form of the number of API endpoints, the number of dynamic pages, which for us would be a page that that we can interact with as opposed to static content. And then we'll kind of wrap up scoping, and that will give us an idea of how much the application test will cost and how much effort will be involved from my team's perspective. And then ultimately, we'll move into the actual penetration test work itself. That's something that will occur in a non-production environment. That's very important. The nature of the testing that we do can sometimes be destructive and problematic. So we really would rather no other users be using the application, and also that the database that the application is connected to is non-production and does not house any crucial client data or anything like that. So we prefer to have test data if we can. Finally, we move into the fun stuff, which is actually logging into the application and doing the work.
That's a thorough overview. Once you start testing, what specific methodologies or frameworks do you follow for web application penetration testing?
So interesting that you would ask that. That is actually very, very important. If you're seeking a web app pen test, is to ask about that methodology. So I'm impressed that you're asking that question. We leverage the OWASP Web Testing Guide version 4.2. I am a contributor for OWASP on a number of different projects. One of them is the Web Testing Guide, and we find that it is an exceptionally thorough methodology. And so that's what we'll use for performing the testing.
That's fantastic. The OWASP Web Testing Guide is indeed a solid framework. How do you typically identify and prioritize vulnerabilities once you're in the testing phase?
So we'll identify vulnerabilities using a couple of different mechanisms, one of which is stepping through the application manually. We want to understand where the functionality is in the application, what different functionalities exist, and we're paying special attention to things that we can interact with, right? So get parameters in the URL. We'll be looking for post requests. And we're also looking at the overall structure of the application. So we leverage Burp Suite Pro, which is a tool that can be used as an application proxy. It's a local proxy that runs on your PC, and you can create a captive browser that will interact well with the proxy, and it kind of captures all of those requests. What's neat about that is you can go into, kind of the application structure and tree, if you will, and we're going to be looking for things that stand out to us, right? API endpoints stand out to us. We'll be looking for, like I said, but post get parameters, any non-standard HTTP verbs, things like put, delete, those things are interesting to us. We're also going to be looking at headers, cookies. If you think about it in terms of information that is controlled by the client, that is our primary focus, and specifically information controlled by the client that is then sent back to the server. And then, we want to see how the server handles it. So you could really boil down almost all of the vulnerabilities that we're looking for in those parameters.
That's a solid approach. Once vulnerabilities are identified, how do you prioritize them in terms of severity and impact?
So those are basically, we'll start with prioritizing them based on severity. There are a couple of different mechanisms out there. We rely on CVSS version 3. And so that specific version allows us to build the vulnerability based on the impact that it has to the system. So we're really big fans of CVSS. And what we're really looking for is the impact to the CIA triad. For those of you listeners that are not familiar with that, it's confidentiality, integrity, and availability. So, what impact to either one or more of those does exploiting this vulnerability have? So, for example, if it, creates an instability within the application, then it might be an availability issue. If we can corrupt the database, then it's going to be an integrity issue. If we can cause the application to stop responding, it's going to be an availability issue. And so it really kind of depends on the severity of the impact to that CIA triad.
That's a thorough way to assess vulnerabilities. Once you've prioritized them, how do you go about reporting these findings to the client?
So we do what we call real-time reporting. So that means, as you're stepping through your process and you identify vulnerability, let's just use cross-site scripting because it's easy to talk about and everybody, for the most part, understands how it works. If we identify a cross-site scripting vulnerability, we will create a proof of concept set of code for that, and we'll actively exploit the vulnerability. We'll take screenshots of that process, and we'll document the URI that the vulnerability exists at. What we want to do, what we're shooting for here, is to give the client enough information to understand and reproduce and ultimately fix the issue. So, depending on the scenario, we might also export a curl command from burp so that the client is able to reproduce the issue on their own. And then we will kind of roll all of that into, the finding package, if you will, and then we'll put that into our reporting platform. And so, people out there who have done testing for extended periods of time can attest to this. If you find something on Monday and then you're trying to write the report on Friday, it really becomes kind of problematic because then you have to go back and remember what you did. So we do this in real time, and that solves that problem, the problem of forgetting what you did. It also solves the problem of clients having to wait, several days, weeks, months, or whatever to get a report. So at the end of the process, since we're doing real time reporting, we basically can export the report, go through a peer review process, button it up, and it's out within 48 hours of the close of the engagement.
That's a great strategy for ensuring accuracy and timeliness. After delivering the report, do you also assist the client with remediation steps?
We do. We actually include references in the report for remediation. And so the first report that we deliver to a client is a draft report. And so the purpose of delivering it in draft form is kind of twofold. So we'll get on the phone with the client, we'll step through the entire report, and we want to accomplish two goals. The first goal is, does the client understand everything that's in the report? Obviously, that's a very important thing, but it's often overlooked. Same thing with agreeing with everything in the report, and that's kind of part two for us delivering that draft to the client because they are going to know more about their internal architecture and code than we will. And therefore, if there are mitigating factors that maybe lower the severity of a particular finding, then we want to know about that and we want to reflect that information in the report. So, delivering that draft report is really important for the client. And then we start the remediation process to more pointedly answer your question. And we have a 30-day retest policy. And so what that means is we're happy to retest as many findings as many times as you want over the next 30 days and confirm that the issues have been fixed. And in all cases, if the client has questions on how to perform remediation, anybody on my team that does a web app pen test is also a web developer. So we can jump on a screen share with a client and step them through. If we need to, we'll jump into the code with them and help them solve the issue. And in a lot of cases, we can point them to libraries or other resources, usually from OWASP, that will help them solve the problem.
That's a comprehensive support process. It must be very valuable for clients to have that level of guidance. How do you measure the success of a penetration test engagement?
That's a really tough thing to do, and it's an interesting question. What we're really looking for is kind of verbal feedback from the client on satisfaction. Ultimately, I think more broadly speaking, the success of a web application penetration test is going to be increasing the security posture or improving the security posture of a web application and its supporting architecture. So we just want the web app to be better afterwards than when we started, right? And so, if we can kick out a clean report, meaning all the issues identified have been remediated, then that's a successful engagement as far as we're concerned.
That's a solid metric for success. It's great to see a focus on continuous improvement. Any final tips for organizations looking to get started with web application penetration testing?
Yeah, there's a couple of things that I think people should consider. One of which is a web application penetration test is not the only way to evaluate and improve the security of your applications. There's a terminology called DevSecOps. I'm not sure that I love that phrase, but just from a uniformity perspective and talking about it, the concept there is to integrate security into the development process. Lots of resources on OWASP about this, but we encourage clients to do that because we feel like it's important. Um, to look at other opportunities, right? And I think the concept behind DevSecOps is to push security as close to the developer as you possibly can. And that really accomplishes two goals, right? One, if you're resolving security issues at the developer level, they never make it into production. And two, the cost of identifying and resolving security issues decreases the further or the closer you get it to the developer. A vulnerability that makes it all the way to production, and then we identify it in a web app pen test, or maybe all the way to test and we identify it in a web app pen test, costs more money because now you have to kick that back to the developer. It has to go back through the entire process to be identified, as remediated. And so it also slows down the delivery of applications, which is something that DevOps does a really good job of, rapid style development. And so we're encouraging clients to leverage those static application scanning, dynamic application scanning. One of the other things that we'll do is put a body in the meetings with the client as they're framing out their functional requirements. Because we feel that security requirements and functional requirements are equally important and should be defined at the beginning of the development process. So if we can build security in at the definition of functional requirements, then we have fewer security issues to find later in the process. So if we kind of look at application security a little bit more holistically, we see that web application penetration testing occurs at the very end of the development process and is the most costly way to identify issues. So using other methods such as static or dynamic application security testing or even planning properly for security can kind of help eliminate that.
That's excellent advice. Integrating security early and continuously in the development lifecycle can save time and resources. Thanks for sharing your insights, Brad.
Good. Thank you for co-hosting with me. I really appreciate it.
You're very welcome. It was a pleasure co-hosting with you.
All right, folks, that's all we have time for today. I hope you enjoyed the episode and found it interesting. I encourage you to go out and check out what AI can do for you guys and kind of how interesting it is. It is this has been an interesting process recording this episode, and so yeah, we'll see you guys next week.
Thanks for listening, everyone. See you next time.